Hello again. Now we're going to work through two different distance problems, or problems where you have to solve for the distance. First one here says, how far has an object traveled? In other words, that's this fancy way of saying how far did it go if it starts at rest and accelerates for 4 seconds. All right, so what do we have here? We know it accelerates for 4 seconds. So 4 seconds here is our time. So we have a time of 4 seconds. And we know it accelerates, but I didn't give an acceleration, so let's just make up one. How about that? It accelerates at a rate of, say, 2 meters per second squared. I forgot to write an original problem, no big deal. There it is. So 2 meters per second squared is our acceleration. How far has it traveled? That's a distance. So that's our unknown. When we look at our different distance formulas, the first one, the d equals vt, that was with no acceleration. We have an acceleration, so we can't use that one. The 1/2 ht squared, that was the second one. That's acceleration starting from rest. Acceleration starts at rest, or from rest. So that we can even label v sub 0 or v sub o is 0. So that's the one we want to use. So we're going to use the second one, which is a 1/2 ht squared. So we don't have to plug in the v sub o because we know that's 0. We simply take 1/2 times your acceleration of 2 meters per second squared times your time of 4 seconds squared. Now, a common mistake that students make, this unit of meters per second squared, that square is not an operational square. You're not going to be squaring anything. If you look at the actual formula, here, the only thing being squared is time. So keep that in mind. Whenever you type this into the calculator, you just have 1/2, which is 0.5, times 2, times your time of 4 squared, you should get 16. And that will be in meters. Easy enough. Look at the second example. How far does an object travel? So again, here we're looking for distance. If it slows down at a rate of -2 meters per second squared, acceleration, like velocity, is a vector, so it has direction. If I'm speeding up in the direction I'm traveling, I'm accelerating at a positive rate. When you slow down, you're decelerating. You may still be going this direction, but you're slowing down, which means your acceleration is in the opposite direction, which we have to represent with a negative. So we have our acceleration of a -2 meters per second squared, time of 3 seconds, starting from 25 meters per second. So that's our initial velocity. So we have acceleration, so we can't use a vt. So it's either the second one, 1/2 ht squared. We use that one if it starts from rest. This is not starting from rest. So we have to use the third one, the lengthier one. So we have the d equals v sub 0 times t plus 1/2 at squared. So we have our initial velocity of 25 meters per second times our time of 3 seconds plus 1/2 your rate of deceleration, which is just your acceleration, of -2 meters per second squared times your time of 3 seconds squared. Now, I'm going to break it down into 2 steps. You can just type it in the calculator all in 1 step as well. That's the beauty of the graphic calculator. But just to show you, 25 times 3 simply gives us 75. If we have meters per second times seconds, those seconds cancel out, just leaving meters. Now we have 0.5 times -2 times 3 squared. 3 squared is just 9. So if you think about it, 0.5 times -2 times 9 gives us a -9. And we have meters per second squared times seconds squared. Those seconds squared cancel out, leaving just meters. 75 minus 9 simply gives us, what, 60, I can't think, 6. I'm not good with numbers. Yes, 66 meters. So that is indeed the distance traveled. If you type it in all in 1 step, you would type it in as 25 times 3 plus 1/2 -0.5 times -2 times the 3 squared, and you still get 66. So my suggestion is to type it in all in 1 step like that, So if you have a graphic calculator, if you're using a little like TI-30 calculator, you might want to break it up like this. But either way, you should still arrive at the same answer, in this case of 66 meters. That's it.